And now for our let's pretend this application is useful part. We have the compound interest formula. So simple interest is the calculated percentage of the initial amount you borrow, add that on. Every time, just on the amount you borrowed. Compound interest calculates interest on your interest. This is what your student loan will use. This is also what credit cards use, but their R's are huge. All right, so A of t is our function notation, but it's the account value or the value after whatever amount of time, but like what is there after the thing. T is measured in years because R is the annual percentage rate expressed as a decimal. So because it's annual, yearly, T has to be number of years. And then we have this extra N thing, which is the number of compounding periods in 1 year. This will be a word in the problem, not a number. So for some people, it can be really tricky because you have to get used to identifying those words. But these are going to be words like monthly, daily, weekly, annually. Then there's biannually, which has debates about whether that's every other year or twice a year. They have to use other words. Nobody knows which way biannual is supposed to go. But semi-annually is definitely for sure twice a year. So monthly is 12, daily we use 365. Weekly we use 52. Annually would be once a year. Semi-annually would be twice. So those are just what the N values would be that correspond to those words. So down here in our first problem, an initial investment of $100,000 at 12% interest is compounded weekly. What will the investment be worth in 30 years? All right, so we're going to pretend inflation doesn't exist, and we're going to pretend you can actually find 12% interest for an investment. Yeah. So in math land, what would happen? So P, the one I skipped over, is called the PreCal, and it is the present value, or often it's the initial investment value. Like it says the more generally present value. I don't like that, but starting value. So our initial investment, there is our P. So we're going to fill in all the numbers and then we just have a formula to crunch. It's a little ugly on the typing in, but that's it. So they tell us our P is $100,000. Our R is 12%, which we would then write as 0.12. Our N, they said compounded weekly. And then they specifically say afterward, use 52 weeks in a year. So sometimes they're nice and they will actually tell you what number to use for N. And they generally should do that, but you know, sometimes math teachers writing problems don't remember. And then our last one is how many years are we looking at? And they said 30. So I have my T, my P, my R, my N. I can plug them in and do the math. All right, so A of T, I'm not going to plug in the T number at first, but this is how, like what we're usually told. We have that initial investment, then the big parentheses, 1 plus Our R is a decimal, 0.12, divided by our n value of 52. And then this is raised to the n times t. So I'm going to put a little set of parentheses up here because if you forget these when you calculate, so I can plug in whatever number I want for t, and this will tell me what is in the account after that many years. All right, so what we're doing for our problem is we're going to plug in 30. So we have 100,000. 1 plus 0.12 over 52, close, raised to the 52 times 30. Make sure there is one big set around the exponent. Make sure there is the set around the 1 plus r over n. It is real easy to like misplace something here, but I start with 100,000 times, open my parentheses, 1 plus 0.12 divided by 52, close, raised to the, mine opens the parenthesis already, 52 times 30, close. So my calculator actually puts the commas, which is really nice. So $3.64 million. So if you could get your hands on $100,000 and the real catch, find an account that will give you 12% interest compounded weekly, you too could have $3.6 million. This is again ignoring inflation, so who knows, maybe that would be worth $100,000. Yeah. Now we can also use this formula to solve for a principal. So if I don't know how much I want to put in the account, but I know after this many years, I want it to have this amount. So here's what we have here is a college savings plan. So you want to set this up. This case, it's Lily setting it up for her granddaughter. She wants it to be $40,000 to grow over 18 years. She believes the account is going to earn 6% compounded semi-annually twice a year. So to the nearest dollar, how much will Lily need to invest in the account now? Okay. So we know our T is 18. We know our N is twice a year. We know our R is 6%, which is 0.06. Our principal is our unknown, but our end amount is supposed to be 40,000. All right. So let's write our formula. I did so many of these in school and as a teacher that I have it memorized. If we ask one of these questions, we will give you the formula. I haven't finished writing the final or compiling it, I should say, so I don't know if it'll be there. I'm hoping not. I think it's just thrown in here as a look application. All right, so we're gonna put 40,000 equals P is our unknown. 1 plus our rate is 0.06 divided by 2 and then raised to the 2 times 18. Okay, so I have P times crazy ridiculous. Crazy ridiculous is something I can crunch on the calculator, and then I can do 40,000 divided by that result. So that's usually the way I end up typing it, just because I like to use the answer feature so I don't have to try to type 40,000 over that, because then you have a whole extra set of parentheses around it. But you can do it that way. All right, so if I'm just crunching that decimal next to P, 1, open parenthesis, 1 plus 0.06, oh, sorry, 0.06 divided by 2, close, raised to the open 2 times 18. So this gives us a 2.89827 blah, blah, blah. So now I'm going to type 40,000 divided by, my calculator has a nice recently calculated. I go find that, hit enter. And lovely Miss Lily needs to invest $13,801.29 and a little bit more cents to the nearest dollar. This is where we get into a little bit of a debate. This is a little bit more than $1, but not enough to round it up to the next dollar. So if we're answering strictly what it says, then our answer would be 13,801. But if you actually do the calculation with 13,801 as the principal, it is going to be a few cents shy of $40,000. It won't actually hit it. So some people would say, well, since there's a little bit more than that dollar, you should just round it up to the next dollar. So I would take either of those answers. I don't know if WebWork will be programmed to take either of those answers. I don't even know if WebWork will ask this, hopefully not. But we can use the formula to find the principal. So we can answer the ridiculous question of, if I get 6% compounded only twice a year, that's a little more reasonable. And I want to get 40,000, I got to start with almost 14,000, of course. Now it says here, what if instead we were going to get it compounded quarterly? How does that change? So let's sure. So quarterly is our n value. So I'm just going to sneak in here and change those to a 4. And now we're just going to do the same calculation, but we're going to see how much that 4 changes things. So open 1 plus 0.06 divided by 4, because it makes the inside smaller, but it makes the exponent much larger. And now it's like 2.92. And now we'll do 40,000 divided by that guy. Uh, so, woohoo! She only has to put a little, like, she'd save $100 if it was compounded twice more often. Yeah. So this would be why you don't The only time you find things compounded this infrequently is when it's you investing money and getting a return. When it's you borrowing money and somebody else calculating interest, then the interest rates are ugly and compounded daily. All right, cut that one there, and then we'll come back and talk about E.